I want you to tell me what these creatures are doing that makes them intelligent. Yeah, cool. So we've got the crow is using tools. We've got orcas, social behavior. Yep, awesome. So I'm going to put here, I think for the crow, I'm going to do problem solving. So what's it doing? It's got to get the right sized cork and the right weight cork to drop it into the water to get the food up. Crows are so intelligent, actually, that they can plan ahead. They are capable of solving problems in a similar way that we would do in chess, where we think moves ahead. Then we've got Picasso, which everybody loves. Picasso is painting here using different colours. So I'm going to put creativity. And then we've got advanced social behaviour, someone said, which is awesome, cooperation. And communication is key between these creatures. Orcas are my favourite animal, by the way. And I'm actually terrified of them and have nightmares of them coming out of the water and just eating me. We've seen what intelligence is. We can see that crows are intelligent, orcas are intelligent, but if we were in outer space and we were looking at the Earth, there's no way we'd be able to see an orca. There's no way we'd be able to know that a crow was using corks to get food out of a bottle. So how do we know that there's intelligent life in space? So we've seen biosignatures. I want you to try and guess what a technosignature might be. Okay, cool. Yay. We have the big buzzword here, which is radio waves, someone said. You guys know a lot. This is really great. This picture is a picture of Seoul in South Korea, and at the back here we've got these big masts on this mountain, and they are probably mobile network masts. They're going to be emitting these things called radio waves. The thing that's different about radio waves and light is that radio waves can keep going in space for a really, really long time, whereas light kind of gets warped and disappears in our atmosphere. Radio waves have been around for a very long time on Earth. We've been emitting radio waves since the 1900s. So the first broadcast, not radio signal that was made, but the first broadcast was made in 1906 by a guy called Reginald Fenison. And what he did was he broadcasted a choir singing Christmas Eve to the United Fruit Company, who were sailing around in the Caribbean and the Atlantic Ocean at the time. And it was a Christmas miracle, all of the angels singing, but they weren't in the same room as them. These signals have been being transmitted from Earth for 115 years. So that means that around the Earth, we have a radius, a big old circle of radio signals going 115 light years. So we've been emitting stuff out into space so far that it could be reaching stars and planets that are 115 light years away. Remember, our nearest star is only 4.5 light years away. So I want you to think about all of the TV and communications and stuff you send every day, and think about if you were an alien species and you were suddenly getting all these signals, how would you figure out the behavior of the human race? What would you think the human race is like? So just while you think about that, I've got a question saying, do they stay strong even as they radiate outwards? They fade quite a lot, not too much, but quite a bit. And the signals we're sending out are actually quite weak. So ideally, I didn't want to go into this too much, but they'd need to have a really big detector to be able to hear it. So we'll talk about that a little bit later on. So I get worried that they'd think we still live in the Middle Ages, that we kill everyone, and that I feel like every TV show that's on Netflix has some complicated murder situation in it. I don't want to be giving that message to aliens. We're actually getting noisier and noisier. And what's more likely is they're not going to get a broadcast that's like a nice, clear, crisp television show. They're going to just be hearing loads of digital noise. Out in space, there are so many satellites now that it's getting to a point where launches are getting concerned about hitting debris that's out there in space. That is a topic for another day. I'll talk about space junk and things like that another time. The main thing I want us to think about is just the fact that out in space we have weather satellites, we've got GPS satellites, mobile satellites, imaging, military, you name it, communications, all sorts of things out there around the Earth that are all quite noisy, sending weird digital type signals. This is actually kind of a problem for radio astronomers on the ground. But radio astronomers are pretty clever and they write really good computer programs that can take away all of that noise from out of space and leave it with the nice space signals, astronomy signals. These are radio telescopes. They look like satellite dishes and they do something very clever. Unlike the Kepler space mission, it's easier to do radio astronomy from the ground because we can build loads and loads of telescopes, and the further apart they are, the bigger the telescope kind of becomes and the further into space we can see. Light from our alien civilization hits this telescope, then a few seconds later it hits this telescope, and that little angle that it makes there tells us where it is, how far away it is, and then our computers can do clever programming algorithms that can figure out whether that signal looks like something we might have seen in astronomy before, maybe a star with a magnetic field that's just exploded, so something like that. Or maybe it's some weird technological signal that kind of looks like our own satellites. So we can use our own noise to tell us maybe that's what a communicating signal looks like. We've got a little robot emoji with bloop written next to it. Yep. So is it a big old bang in space or is it a little robo bloop? I'm going to write bloop next to it. I like that. The group that write a lot of these algorithms to look for aliens and do all the computer modelling to figure that out are a group called the SETI Institute, and SETI stands for Search for Extraterrestrial Intelligence, and this picture is of their observatory in Northern California. I want us to move on now to just a little bit of maths. So fun maths time. Thought you could escape maths, but you can't. I want us to do some little maths problems. I'm going to roll one dice. I'm going to roll this dice here. And I want to roll a 4. What is the probability of me rolling a 4 with one dice? Okay, cool. We've got 1 in 6. So we've got 1/6. Awesome. Good going. I'm going to ask a harder one now. I'm going to roll both of me dice. And I want the sum of the dice to be 3. Does anyone know what the probability of that would be? We've got 1 in 36. Okay, so getting there. Cool. Okay, so if I want the sum to be 3, then on the first dice, I could roll a 1, and then on the second dice, I would have to roll a 2. Or my only other option is that I would have to roll a 2 on my first dice, and then I'd have to roll a 1 on my second dice. The total number of options we've got here is we've got 6 on 1 times 6. So we've got 36 different possibilities. And we can only get 2. That means that the total number is 3. So that's 2 out of 36 or 1 out of 18. So that would be our probability. When it comes to the probability of life, we end up getting a really complicated game of cosmic dice happening. This can be sort of thought of as being a thought experiment. And this thought experiment, known as the Drake equation, was put across by a scientist at the SETI Institute called Frank Drake. What this probability thing does is it makes us think about how likely intelligent life is of contacting us. So the first thing we kind of need to know is how fast do stars form. We need to know that because we need to know how many stars there are. We need to know how old those stars are, and whether or not those stars have been around long enough for planets to form. So then the next thing is, how many of those stars have planets? Then we need to know the number of planets that can support life. So we're getting less and less likely as we go down. Then we need to think about how many of those will go on to develop life. Because if it's a really early planet, like the early Earth, then it might not have supported life yet. Or it just might not have had the right ingredients to be able to do that. Then we think about how many of those actually develop intelligence. So are there alien crows on the planet that are solving problems to get their snacks? And at what point are those alien crows going to be able to start sending signals to us? And then the last thing we need to think about is how long have those signals been being sent out in the first place? Because we saw Alpha Centauri, that's 4.5 light years away. Well, if last week some aliens on Alpha Centauri suddenly did their United Fruit Company emission, sending out that radio signal, we're not going to get that for 4.5 years. So right now we could be like, it's very unlikely that there's life, but in 4 years' time maybe we'd find that signal. So it's exploring the possibility of there being life out there. So I want to go back to that little looking for life versus listening for aliens. Looking being trying to find signatures of space slime, algae on other planets, maybe there's liquid water. That's looking for signs of life. That was our biosignatures. And I've got a picture of the James Webb Space Telescope there. Now, it's very likely that there's going to be space slime because we've seen how there's loads of different life on Earth that can live in really harsh conditions. So that's pretty likely. But what's unlikely is us being able to build something that's sensitive enough to be able to detect it. It's likely, but it's going to be hard to find. Whereas listening for aliens with our big radio telescopes, we know that that's pretty reliable. It's very easy to do. We can do it on the Earth. We can do it with the more telescopes we have, the better chance we have of doing it. But what's the chance of there being intelligent life out there? This was very unlikely, as we saw, because there's so many different dice we have to roll to be able to form that intelligent life. So I want to ask you, which of these do you think we'll figure out first? Do you think we'll find a planet that we can say, yeah, there's definitely life on there because we've seen all this greenery with our space telescopes? Or do you think it's more likely we'd hear a weird technical signature? Me personally, I think I get more excited by the idea of there being things like space whales out there, like big, huge ocean worlds with giant whale creatures, really highly developed social things going on. That really excites me. But I think we probably detect technological signals first. So the last thing I want to say is, do you think that there are aliens out there looking for us? What do you think? Do you think we're more likely to be detected before we detect them? Oh, we've got one question. Have we ever heard something looking like aliens from space? Yeah, actually quite a few times. Loads of radio astronomy discoveries were originally thought to be alien signals, but then what happens is that they team up with observational people and they look at where it was in space, and then there's people that do computer models of stuff, and they usually narrow it down to being some weird phenomenon like a star exploding, because the power is just too great for it to be maybe something artificial, or maybe it's just behaving in a way that we've seen in nature. Remember that space is nature as well. These things that happen in space, like stars exploding, black holes colliding, dust going around galaxies, accelerating particles and things, it's still nature. And astronomy is a natural science as well. So there's signals that we get that we like to think of it being a kind of natural signal, but sometimes it takes a few years of computer modelling and lots of follow-up observations to try and find out whether or not that's actually happened. Please follow us on social media, sign up for our newsletter, and also soon we've got a climate course coming up. So the reason I wanted to talk so much about whales and the diversity of life on Earth and what you would ask an alien is because what's the point of looking for aliens if we can't sustain our own planet and look after it and all the insanely cool diverse life that is out there?